We have this three-dimensional vector field, which is conservative, and now our goal is to try to find a potential function. So we're looking for a multi-input function, little f, of x, y, z, where the partial of f with respect to x should equal 2x minus y minus z. If the gradient of f's middle component should be 2y minus x, then we need f sub y, we need the partial of f with respect to y to be 2y minus x. And we also need f sub z to be 2z minus x. So let's take this right here and just integrate both sides with respect to x. And so f should equal x squared minus xy minus xz plus, we'd say a constant, but this is just a constant as far as x is concerned. So let's say we could have a function of y and z. In other words, f will look like this: x squared minus xy minus xz plus, and now we're no longer allowed to mention x. Now if we want to incorporate the fact that the partial derivative with respect to y is 2y minus x, let's, well, partially differentiate this with respect to y. So you're going to get negative x plus the partial derivative of g with respect to y of yz. And so we have two different ways of writing f sub y right now. One is 2y minus x, one is negative x plus g sub y. So let's just set those equal to each other. Negative x plus g sub y of yz is equal to 2y minus x. We can add x to both sides to see that the partial derivative of g with respect to y is 2y. So when you integrate both sides with respect to y, then you just get g of yz is equal to y squared plus a constant, but it's just a constant as far as y is concerned. So we could call this a function h of z. In other words, what's the function g look like? G is a two-input function, which looks like y squared plus, you can no longer mention y, but you can mention z. We don't know yet. What we can do now is take the f that we had earlier, we knew f looked like this, and now replace the g of yz with what we have here. So we know that our function f of xyz is x squared minus xy minus xz plus, now replace the g of yz with y squared plus h of z. What is h of z really? Well, we're going to need to incorporate this last fact that talks about f sub z. So let's differentiate partially with respect to z and get negative x plus, I guess here we can just write h prime of z. So then we have two ways of writing f sub z right now. One of them is negative x plus h prime of z. The other way of writing f sub z is 2z minus x. I guess here add x to both sides, and h prime of z is equal to 2z. And so h is equal to z squared plus, now I guess we could just use a c, because now this c should just be a constant that cannot mention z either, cannot mention x or y for that matter. And now we'll go back to the last way we've written f and put all this together. So f of x, y, z is x squared minus xy minus xz plus y squared plus, and the h of z can be replaced with z squared plus anything you want for c. So we could just use any old number like 3, and this is a potential function for the vector field capital F, but perhaps the most useful c to use is just 0, if you think about what you normally do when you use the fundamental theorem of calculus 2, part 2. So you can just check, right? Now take this function of 3 inputs and find the gradient, and you should get this vector field up there. What's the punchline? The whole point of finding a potential function was because you probably had an integral of this sort, right? You had an integral over some path c of vector field f dr. And if you're ever faced with a line integral over a vector field, which is conservative, one way to do this is, and let's just say, I'm sort of making this up on the spot, I should have maybe planned this out, but let's just say you have some curve in three-dimensional space, like that, that's C, and let's say you start at the origin, and let's say you end at the point 3, 4, 5. Well, if that's the case, when you have a potential function, that just means you need to take little f at the terminal point. So in this case, 3 squared minus 3 times 4 minus 3 times 5 plus y squared 4 squared plus z squared 5 squared minus, and then you need to evaluate f of 0, 0, 0. Well, that's just 0.